In this presentation, we'll be reviewing junctional rhythms and AV blocks. Just note that you should have already watched the intro and atrial rhythms presentations prior to proceeding to this one. Moving on to junctional rhythms and AV blocks, we're basically moving down the heart. You can see here the area of the heart we'll be focusing on. So how does this translate into the PQRST complex? Well, we're now looking at the PR interval. And now because some of the rhythms will impact the atria, you'll be assessing the P wave as well. And even you'll see how this might impact the ventricles. Beginning with junctional rhythm, what is going on here is the SA node has failed to fire. Additionally, none of these F waves or chaotic atrial ectopic foci have really taken over to rescue the heart either. So now the cells around the AV node in the junction of the atria and ventricles are going to rescue the heart in a sense. So remember that these cells in the AV node have automaticity, where they can start a beat at a regular rate, acting just like a pacemaker. However, their natural rate isn't the 60 to 100 rate that we see with the SA node. The junctional cells have an intrinsic pacemaker rate of only 40 to 60 beats per minute. So immediately you know that a junctional rhythm will be slow, 40 to 60 beats per minute. So what else will we see? Well, there's no P wave because the SA node didn't fire. So instead, the way the junctional cells show up on the EKG strip is either an inverted P wave, sometimes even coming after the QRS, or simply no P wave at all. So because of this slow junctional rate of 40 to 60, you might start to see that your patient's cardiac output is decreasing as well. Here you can see a few examples of junctional rhythm. Notice the absence of a P wave, an inverted P wave, and a P wave after the QRS complex. These are all considered junctional rhythm. So next we're going to discuss AV blocks, or atrioventricular blocks. And the key thing to remember here with AV blocks is that the AV node automatically pauses the electrical signal. Remember, that's our PR interval, that flat line. So with AV blocks, there's an issue with that pause. It's either too long, it doesn't allow signals to go through consistently, or it's completely blocked. So you'll see we have first degree block, second degree AV block, and that actually has a type 1 and type 2, and then the worst, which is third degree AV block. So in first degree AV block, it's really quite simple. All we have is a little bit too long of a pause at the AV node. So remember, with AV blocks, we're looking at the PR interval. So a normal PR interval is 0.6 to 0.20 seconds. But in first degree AV block, the PR interval is longer than normal, over 0.2 seconds. So the key thing to remember here is that is all that is wrong. We will still have a regular rhythm. We will still have good P waves. They're still going to look normal. We still have one P wave to every QRS. Our QRSs are still within normal limits, less than 0.12 seconds. The only thing wrong here is a prolonged PR interval, and it's consistent. So for example, if our PR interval were 0.38 seconds, it should be 0.38 seconds on every PR interval for the entire strip. In second degree AV block, remember there's two types. And the first type, second degree AV block type 1, also called Winky block, here we're looking at an inconsistent relationship between the P wave and the PR interval. So basically, our AV node is pausing the signal a little bit longer each time it gets a signal from the atria, and it ultimately completely blocks the signal. So we see progressively longer PR intervals followed by no PR interval, or just a lonely P wave with a dropped QRS. And then the process starts back up again. So a helpful way to remember this is the rhyme, longer, longer, longer drop, now you have a Winky block. Just note that it's not always this nice rhythm. It's sometimes longer, 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 longer. Sometimes it's longer, longer drop. But ultimately, your PR intervals are getting progressively longer until there's no PR interval to measure because there's no QRS. So in our second type of second degree AV block, also known as Mobitz 2, the signal isn't getting paused for longer, 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 and then dropping. It's just occasionally dropping QRSs. So what you have is certain P waves that lead to a QRS and others that don't. And in the actual PR interval for conducted beats, for P waves that lead to a QRS, the PR interval is the same. So you can see where the red arrows are above. Those are called conducted beats. And the PR interval for those, all of them should be the same. All of those should match. However, you also see lonely little P waves out there with the blue arrows with no QRS from time to time. So this is where that block is occurring. The signal is stopping at the AV node and nothing is getting through. And sometimes there is a ratio, so maybe every third P wave leads to a QRS, but sometimes it's inconsistent. Now the last AV block. This is third degree AV block or a complete heart block. And the best way to think about this AV block is that the atria and ventricles are no longer communicating. The AV node is completely blocking all communication. So what we have is an SA node that's consistently beating at its intrinsic rate of 60 to 100 probably, almost seeming oblivious to the fact that there's a problem below. So imagine the ventricles sitting there with no signal. The AV node has blocked all of those P waves. So in a sense, you can think about the ventricles beginning to panic. No one's sending us a signal, so they begin to rescue themselves, but not very well. Remember how the SA node and AV node have automaticity? Well, there are parts of the bundle of His that have automaticity as well. Now these cells have an intrinsic pacemaker, but it's not very good. It's not the 60 to 100 like our SA node and not even the 40 to 60 like in our AV node. The intrinsic pacemaker in the ventricles is 20 to 40 beats per minute. And because the signal's coming from the bundle of His, our QRS gets distorted. It's no longer skinny and efficient in less than 0.12 seconds. It's wider and slower. So what does this look like? Well, basically think of it as two hearts, an atrial heart and a ventricular heart, or an atrial rhythm and a slow ventricular rhythm. And they just happen to be sharing the same piece of paper, the same EKG strip. But because they're on the same strip, they might actually fool you into thinking that there's some kind of relationship between the P waves and the QRSs, but there isn't. You can measure the PR interval because they're sharing the same piece of paper, but you start to realize that it doesn't really make any sense. There's no longer drop or anything. And one of the hallmark signs of third degree AV block is that wide QRS. So you'll look for a steady amount of P waves and then infrequent but steady QRS waves that are wide. So the P waves will actually be quite regular because they're coming from the SA node, and the QRSs will actually be quite regular because they're coming from the same pacemaker too. They just aren't communicating to each other. So you've essentially stacked two independent rhythms on top of each other sharing the same line. But the bottom line is, how is our cardiac output? Well, we have 20 to 40 ventricular beats per minute, and they're not the greatest looking beats. So this is very dangerous, and that's why it's called a lethal dysrhythmia. This is a rhythm where you need to intervene immediately and speed up the heart rate.